Now, is there a shorter and a faster way to solve this question rather than this? Yes, there is, all right? But to understand this, we need to go back to the basic and understand what is an expansion, all right? So let me give you an example of this. So let's just say I have 2, right? A plus B, okay? Now, we understand this as a multiplication because we have 2 next to a bracket, it means multiplication. But for this example, I'm gonna change the location of 2 because it doesn't matter how the numbers are arranged in multiplication. For example, 2 times 3 is 6. If we were to swap it, 3 times 2 is 6 as well, right? So it should be the same if I write it as A plus B and I put 2 over here, right? Okay, now why do I arrange it in this way? Because I want to relate this to this over here so you can see better, right? So basically what you see over here is the same thing, but in this example, I'm going to show it in this way. Yeah? So I'm just going to erase this one. Now, let's take a look over here. Okay, now same thing over here. If I want to expand this, all right, if I want to expand this, all right, I can write as A times 2, right? So A times 2, I can write as A times 2, okay? And then similarly, I can write as, the operation here is an addition. So I'm going to write an addition over here, okay? And then I have B times 2. So I'm just going to write that down. All right. Now, why am I writing it this way? I am going to bring this equation, all right, down over here and for you to compare it directly. All right, you might notice a similar pattern over here. All right. Now, of course, like before I bring this down, this one, if we were to do our mathematics, so of course this will in the end become our 2a plus 2b, right? Right? But I'm not interested in the final answer. All right, I'm interested in this step over here. Okay, so let's see what happened when we bring this down. So I have 9.2 there. All right, 9.2 times 10 to the power of 4. Okay, and my operation here is an addition, and I have 8.3 times 10 to the power of 4. All right, now notice something similar over here. Now this pattern and this pattern looks the same, right? Okay, in fact, because you see 2 and 10 to the power of 4 and 10 to the power of 4. Now let's take a look back at this equation over here. Now this equation, A times 2 plus B times 2, originally comes from where? It comes from this guy over here, all right? So since this equation has the same pattern, so we can also write this equation in this way, right? So in this case, this 10 to the power of 4, we can factorize it out. Same thing as this 2. Okay, we can factorize it out to write this way. Okay, so what do I do over here? Now I will take 10 to the power of 4 and factorize it out. What do I left behind? 9.2 and 8.3. So these two numbers will just add together, all right? Like what you can see over here with this equation and this, all right? So I can rewrite this as 9.2 plus 8.3. Okay, let me put. Excuse me. Now, since I already factorized this out, I can rewrite this as multiply 10 to the power of 4, right? So take a look at this form, right? It looks similar, right? So a rule of thumb is, all right, if I am multiplying the same number over here, like you see here, you can factorize it out, all right? Okay, now, in the end, let's solve this. 9.2 plus 8.3, we should get 17.3. times 10 to the power of 4. Now that is the reason why I put the 10 over here, because in the end, based on our question, we want to write our answer in standard form. So I will prefer to put it on the left instead on the right. Okay, but it's the same thing. Okay, you can rearrange it anytime. Okay, so over here now, once we get to this already, right? Once we get to this, take a look at this, right? Over here, okay, over here, that's not our final answer, right? Despite of how similar this look like to a standard form, but we can see that this is not a standard form. All right? Can you identify why is it not a standard form? It's because of this number here. This number here is 17.5, which is bigger than the range that is accepted in A. All right? We write our standard form in this way, A times 10 to the power of n, where this A must be 1 to 9.99. Right? But since this is 17.5, it's bigger than this, so this is not a standard form. All right? So after that, I would want to change this to a standard form. So what do? Okay, you can do the basic way, right? You can expand this out and then convert it back to a standard form. All right? Okay. But however, there is another shortcut over here to solve this. I will explain that in another video. Now, over here, what do I do next? I would like to play safe. So this is my starting point over here. And I'm power of 4, so I know I have to jump to the right hand side. So 17.5 over here. I will jump 4. So 1, 2, 3, 4. So in the end, I will have 17.5000, right? So in the end, I will just identify my start and end point, which is this 2. This is my start, this is my end, and then all I need to do is to jump 1, 2, 3, 4, 5. So as a summary, my final answer will be 1.75 times 10 to the power of 5, right? Same answer, okay? So, but this is another alternative way to do, right? Again, if you notice they are the same power, you can just factorize it out and then just add together the number. But you have to be very careful. You have to look at the answer over here. Does this answer fit in the range of 1 to 9.99, right? If it's not a standard form, right? Like in this case. So you have to take this number and change it into a standard form.